Welcome to our favorite YouTube channel DCD Electrical Knowledge. Today's goal is to learn electrical power and electrical energy. Electrical power and electrical energy. Let's start the electrical power and energy. I think that before studying the electrical power and energy, it is necessary to know about the potential difference and work done. Now, work done indeed is a form of energy transfer to or from that object. Electrical energy theorem, according to electrical energy theorem, it states that the net work done by force on an object equals the change in its kinetic energy. That is, work done is able to change the kinetic energy of the object. When a charge moves from one point to another point, the amount of work done, W, is to be done by electric field. So, the potential defines as the work done per unit charge. Let us see, in an electric field or a conductor having 2 points A and B is placed in an electric field having the potential VA and VB. When a charge Q is moved from A to B, some amount of work is to be done. Let the work is W. Then potential difference VB minus VA, that is final or minus initial, is equal to work done W by time t. Work done W by unit charge Q. So we can write the difference del V or V is equal to W A to B, work done from A to B by Q, or V is equal to W by Q. That is, work done W is equal to V into Q. charge, we can write V is equal to I into T. We know that I is equal to Q by T. What is this? Now, in a cross section, the rate of flow of charge is known as current. Current Q, which is charge, T is equal to time, charge in coulomb, C, time in second, and current I is ampere. Okay, now we can write V work done is equal to VIT is equal to I square RT is equal to V square by R into T. Now we can see the work done W is equal to VIT or I square RT or V square by R into T. That is E. E means energy. We know that the work done is transformed as energy into a body. So we can define the electrical power. Electrical power is nothing but a rate of doing work. Rate of doing work. Key work, electrical work. Rate of doing electrical work. Doing electrical work. W. So we can write in T second the amount of work done is equal to W. Then in 1 second the amount of work done is equal to W by T. This W by T, that is the rate of work done, is known as electrical power. Also, electrical power P is equal to W by T. Rate of doing work. W is equal to VIT by T or I square RT by T or V square RT by T. So if that is VI or I square R or V square R. Well, this is the formula of electrical power. Now, what is the unit of electrical power? In SI unit, work done W is joule per second. So, in SI unit. So in SI unit of work done of electrical power is joule per second. This joule per second is called watt and denoted by W. Okay, this W is work done WD denoted by the work done. WD work done. The watt. Now P is equal to VI when V is equal to 1 volt and I is equal to 1 ampere, then P is equal to 1 watt. So what is the definition of 1 watt? When V is equal to 1 volt, I is equal to 1 ampere is passing through a conductor, the power consumption is to be 1 watt. Okay, what do you mean by 1 watt? An electrical machine which use 1 joule electrical energy per second, then its power is 1 watt. What do you mean by 220 volt 100 watt bulb? It means that when means that it means that when the valve is connect 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 in 220 volt supply 220 volt supply, it consume consumed or used 100 joule electrical energy per second. 100 joule electrical energy per second. Hope it is clear to all. This concept is very important. We know that P is equal to W by T, and this W, that is work done, is the energy of the conductor. So from this we can derive P into T is equal to E. So we can say that electrical energy is nothing but the product of electrical power and time. তাহলে electrical energy electrical energy is the product of electrical power P and time T. Okay. So we can write the unit of SI unit of electrical energy is watt into hour. Symbolically WH. Kilowatt is the practical unit. 1 kilowatt is hour is equal to 1 kilowatt into 1 hour. Clear? Watt hour is a small unit. Practical unit kWh. Practical unit is kWh. 1 kilowatt into 1 hour. 1 kilowatt is equal to 1000 watt into 1 hour is equal to 3600 second. That is 1000 watt. Watt means joule per second. Joule per second into 3600 second out. So 1000 into 3.600 joule, that is 3.6 into 10 to the power 6 joule. It also be noted that 1 kilowatt hour is known as BOT unit, Board of Trade Units, or commercial unit. The distribution companies of electrical department, electricity distribution companies are used 1 BOT or 1 kWh is equal to 1 unit. Hope it is clear to all. Do like, share and subscribe my channel DCD Electrical Knowledge. No more today. Thank you.